In this video, we are going to be exploring quadratic functions. By the end of this video, you should be able to recognize the characteristics of a parabola, which is the graph of a quadratic function. We're going to understand how the graphs of parabolas are related to its quadratic function, so we could be able to look at the graph and say, oh, we know this information about the quadratic, or here's a quadratic, this is what we know about the graph of the parabola. We're going to determine a quadratic function's minimum and maximum values, and these are guaranteed to have a minimum or a maximum, not both. We're going to solve problems involving a quadratic function's minimum and maximum value. So here's some warm-up questions. And the first question, and I'm going to answer it at the end of the video, or you may be able to answer all these at the end of the video, is it possible for a function to have more than one inverse? Now this is asking about information that we learned actually in chapter 1. So if you're still not sure about that one, go look at your chapter 1 notes or open the Openstax book, Pre-Calculus, chapter 1, and it's going to talk about inverses. Is there any function that's equal to its own inverse? Again, that's a chapter 1 question, but I will answer it at the end. And are all one-to-one functions always increasing or decreasing? Again, that is a chapter 1 question, but I will still answer this at the end of the video. So first we're going to talk about what a polynomial function is generally, and then we're going to look specifically at a polynomial function that is a quadratic. Polynomial functions will have the form, this is only in one variable. I know there are polynomial functions in multi, we're only focusing on one variable. So f of x equals some a sub n, x sub n plus ... all the way down to a naught. Now typically we like to subscript simply because of the fact that we like to know the position of where this number is coming from. And this subscript, notice it is n, and this exponent or power is n. That tells me if I told you a sub 3 is equal to 5, that I know that that is the coefficient on the term that has x raised to the third. So that's what the subscripts do, is pair this stuff up. Okay, some of the properties. When we have a sub n, x to the n, this is the entire thing is our leading term. The degree is the n, the leading coefficient is the a sub n. So the degree is n, the leading coefficient is the a sub n. And the reason we care about that is because we can determine what the graph looks like or expects to look like just knowing this information, what the leading coefficient is and what the degree is. When the polynomial is written in this form, we say it's in the general form. And the thing about polynomials is that they need to be in descending order to be in general form. And what I mean by that is that I need to have the highest power first leading down to any constant. So as an example, if I say f of x is equal to 3x to the 4th minus 5x to the 7th plus x, this is not in general form. General form is negative 5x to the 7th plus 3x to the 4th plus x. Now if I was asked what the leading term is, this entire negative 5x to the 7th is my leading term. My degree of the polynomial is 7. My leading coefficient, a sub 7, is negative 5. So now I have the information about the polynomial, and I can tell you what the behavior of the graph should kind of look like, at least as x goes to negative infinity, as x goes to positive infinity. I can tell you that information. What happens in between, we're going to work that out. The other things about polynomials is that the degree of all of the powers on all of the variables have to be whole numbers. So 0, 1, 2, 3, all the way up. It cannot be fractions. So what I mean by that is if I were told you that f of x is equal to x squared plus x raised to the 1/2 plus 3, this term right here, because that exponent is not a whole number, it is not 0, 1, 2, 3, we know that this is not a polynomial. Also, if I would have had f of x is equal to, say, x squared plus x raised to the negative 1 plus 5, this is also not a polynomial because negative 1 is not a whole number. So not only can we not have fractions, can't have decimals, we can't have negative exponents for it to be a polynomial. When we have a polynomial, we are guaranteed at most n minus 1 turning points. And we are guaranteed at most the n number of x-intercepts. We're not guaranteed on certain polynomials to have an x-intercept. And we are not guaranteed on polynomials to have turning points. Now, if you remember what a turning point is from chapter 1, a turning point is when we go from negative increase. So we're going from increasing to decreasing or decreasing to increasing. So again, chapter 1, Openstax. So that's what a turning point is. So if we take a look at a polynomial that we looked at in chapter 2 of the Openstax book, those are lines. So f of x is equal to 3x plus 1. My degree is 1. My leading coefficient is 3. And since I have n minus 1 at most turning points, if n is 1 minus 1, so that gives me 0, which was what we expected on a line. Now, we expected this to happen because it's a straight line. There's no curves in it. And we will have one x-intercept. Will we always have a y-intercept? Well, yeah. We're always guaranteed a y-intercept because we can set x equal to 0 at any time. Even if we have a constant, we can set this thing equal to 0. So we're always guaranteed a y-intercept. Will we have more than one? No, because it won't pass the vertical line test. So it's not a function. So it's not a polynomial function, I should say. It's not a polynomial function if it has more than one y-intercept because it won't pass the vertical line test. If we take a look at determining by looking at examples of degrees, leading term, leading coefficient, max number of turning points, max number of x-intercepts, you could fill out this chart for any polynomial of degree anything. So we're going to start with a constant. So the function notation as f of x is equal to some constant. We're going to say 3. 3 is a nice number. The degree is 0. And the reason it's the degree 0 is because right here I don't see an x. So that means what I have is x raised to the 0. I can rewrite this as 3x raised to the 0 because x raised to the 0 is 1. The leading term is just 3. The leading coefficient is just 3. And again, I can write x to the 0 there, but I don't need to have x to the 0. The max number of turning points, because this is 0 minus 1, we're not going to have any turning points. Because I have x to the 0 minus 1, I can't have negative turning points. And we also know this is a horizontal line. Max number of x-intercepts, we have none, or we have an infinite amount. You're like, what? So if I were to graph a horizontal line, and I've got f of x is equal to 3, here's my horizontal line, this is never going to cross the x-axis. However, if I say f of x is equal to 0, it's still a horizontal line. It is the x-intercept, or the x-axis, so there you have it. It's infinite. But for us, we're going to say no, unless it's a special case. Linear, we talked about earlier, so f of x. I'm going to use a different number, so I'm going to do 5x minus 2, or I put 1, whatever. The degree is 1. The leading term is 5x. The leading coefficient is 5. Max number of turning points is 1 minus 1, so we have 0. The max number of intercepts is n, and that happens to be 1. Quadratics, which is what we are going to be focusing in on this video, f of x is equal to negative 6x squared plus 2. The degree is 2. The leading term is negative 6x squared. The leading coefficient is a negative 6. Max number of turning points, 2 minus 1, which is 1. And I'm going to say right now, quadratics are guaranteed to have one turning point. They are guaranteed to have one turning point. The max number of x-intercepts is 2. We are not guaranteed x-intercepts when we have quadratics. An example of a cubic would be f of x is equal to 4x to the third, maybe an x plus 5. The degree is 3. The leading term is 4x to the third. The leading coefficient is 4. The max number of turning points is 3 minus 1, which is 2. And the max number of intercepts is 3. With cubics, or any odd-powered polynomial, You're not guaranteed any turning points, but you are guaranteed one x-intercept. We could have up to 3, but I may not have 3. I could have 1, I could have 2, I could have 3, but I am guaranteed at least 1. The quartic, so let's do f of x. F of x is equal to negative 42 x to the 4th, maybe 3x cubed, maybe an x, maybe a 1. The degree is 4. The leading coefficient is negative 42 x to the 4th. The leading coefficient is negative 42. The max number of turning points is 4 minus 1, which is 3. And the max number of x-intercepts is 4. Odd powered ones, so like the cubic, the linear, the power of 5, etc., are guaranteed an x-intercept. We know we'll have at least one x-intercept. And we're not guaranteed any turning points, but we are guaranteed at least one x-intercept. The ones that are even, quadratics, quartics, may or may not have an x-intercept. Okay. Graphs of polynomials are always smooth. There's no kinks, there's no corners, they're continuous, which means that you can draw the graph from left to right or right to left without picking up your pencil. Domains are always all real numbers unless it's restricted by the application or by the story problem that's attached to that polynomial. So your domains are always going to go from negative infinity to infinity, or in interval notation, your variable, such that your variable belongs to the real numbers. So set builder or interval notation. Quadratic functions are polynomial functions of degree 2. That's their the highest power or the highest degree on the variable. The graph of quadratic functions are U-shaped. They're called parabolas, and it will always have one and only one turning point. And that turning point, or the extrema, is called the vertex, and it is noted as h, k. If the leading coefficient is positive, then the graph will open up and it'll look something like that. If the leading coefficient, make sure you change that on your notes, is negative, it will open down and it'll look something like that, U-shaped like that. The graph is symmetric about the axis of symmetry, and this vertical line is denoted as h, or x is equal to h, where again, h is from up here. You can see h is the x part of the vertex. Quadratics can have real number or imaginary number for zeros, and quadratic equations can have real number or imaginary numbers as solutions, which means the zeros may or may not be the y-intercepts. You're like, what? If I gave you f of x is equal to x squared plus 1, we know from the chapter 1, the transformations of graphs, this is the parent or toolkit of functions that is the quadratic that has been moved up once. So we can see that the graph would look something like this. If you're like, I'm not totally understanding, that's okay. Let's set this thing equal to 0. So x squared plus 1 is equal to 0. So x squared is equal to negative 1. And we know from the video in 3.1, we can take the square root at the moment of a negative number. So x is equal to plus or minus the square root of negative 1. So x is equal to negative and positive I, or 1i. So we get a solution. It's an imaginary number or complex number, which means that our solution to the quadratic is not the x-intercepts. So what happens when they are the x-intercepts? Well, if they are the x-intercepts, that means our solutions must have been real numbers, and we know that we are crossing or touching at that place on the x-intercept. Now, this, what we're going to learn is that we're going to take x-intercepts and build the quadratic if we're given the x-intercepts and if we're given the vertex and another point. So we know that when we are solving a quadratic, we would have had some kind of quadratic here, something here is equal to 0, and something here is equal to 0, and then we would have said x is equal to some number, and then here we would have had x is equal to some number. So let's go backwards. So for this quadratic, we have x is equal to -1, so x plus 1 is equal to 0. And for this example, I have x is equal to 3. That means x minus 3 is equal to 0. That means my quadratic is x plus 1, x minus 3. And there is my quadratic in factored form. Here's some questions to ponder. What would be the domain and range of the quadratic where the coefficient is greater than 0 or when the coefficient is less than 0? Now notice what we have done here is that we don't have a subscript of a sub 2 on either one of these. And the reason is because we're going to start to write this in the general form of a quadratic. That's down here as a preview. And that allows us to be able to use a quadratic equation to find the zeros if it doesn't factor nicely. But that's not the range. Now, what we know is if I were to talk about the range where a is greater than 0, it's going to look like this. That means for this particular quadratic, I'm going to have a min at x is equal to h, and the min is k. So if the minimum is k, the range of this particular one would be from k to infinity. When a is less than 0, it's going to look like this. So at that vertex, h comma k, I'm going to have a max. So I'm going to have a max of k at x is equal to h. So its range would go from -infinity to k, including k. The graph may or may not have an x-intercept, but it will always have a y-intercept. Well, that's because we can only set the variable equal to 0 and solve for y. When we set y equal to 0 and solve, as you can see from up here on this example, I ended up with a complex number, which means I have a quadratic. It's a beautiful quadratic, but it's not crossing the x-axis. So here are the two forms that we normally see. We also can see it in factored form. The general form of a quadratic is ax squared plus bx plus c, where a, b, and c are real numbers, and a is obviously not 0. If a was 0, then I have a line, not a quadratic. The standard form is in the a, this is the leading coefficient, x has a coefficient of 1 inside the parentheses, x minus h, quantity squared plus k, where the vertex is h comma k. H can be found in the general form as doing -b over 2a, and k can be found by plugging an h into the original function and solving for k. At this moment, we're just going to accept this is true. In Calculus 1, we're going to prove this is true, but for right now, let's just accept this and move on. So we have the general form, which is the general form of polynomials, and then we have the standard form. This is also, the standard form is also sometimes known as the vertex form, because it tells you the vertex immediately. And this we answered in the questions to ponder earlier. So they noted it as f of -b over 2a. This is k. And then again, we have f of -b over 2a. This is k, where the f of -b over 2a is the smallest point. It is the smallest, so it is a minimum, and we have the maximum here. Again, this is the form. And questions to ponder, I think we may have already answered this above. We talked about this one up above, and we talked about this one up above. Given the graph of the quadratic function, write the equation of the function in general form. Here are the steps that you can take to write it in the general form and the standard form. So the standard form will help start us, and then general form is after we clean it up. Pause the video at this point, write these down if you need them, or read through them if you have the notes printed in front of you. So following these steps loosely, is I'm going to start with figuring out what the vertex is. So the vertex of this first one is going to be -1, comma 2. So I'm going to start with the standard form, which is f of x is equal to a, because I don't know what that is yet, x minus my h is -1, so -1, plus k, which is 2. So this is equal to a, x plus 1 plus 2. Now, to figure out what a is, I need a point that is crossing a grid mark, or they need to tell me it's going to go through a point. And if I can use a point that's on the y-axis, I will. If it crosses the grid mark nicely, I will use that. And this one it does. It's going to cross the point 0, comma 3. So what I'm going to do is I'm going to put this point into this function. So we know that f of x is, I can replace f of x with y. So replacing these numbers, I'm going to have 3. Actually, let me do this in blue so I have a consistency. So 3 is equal to a. My x is 0 plus 1 plus 2. So I get 3 is equal to 0 plus 1 is 1 times a is just a plus 3. And then, or plus 2, excuse me, plus 2. I'm going to go ahead and subtract 2 from both sides, and I'm going to get 1 is equal to a. So my function in function notation is f of x is equal to 1. Oh, that should be a squared right there. Should be squared. This should be squared. This should be squared. Is equal to 1, x plus 1 plus 2. Don't forget to square that. Now, if I were to expand this out and put it in not the standard form, but the general form, this would be x squared plus 2x plus 1 plus 2. And that is expanding out a perfect square trinomial. And so I get this is equal to x squared plus 2x plus 3. And there it is. Now I'm going to do this next one, and then I want you to pause it, and I give you the answers to the next two. So on this next one, this is C. I have a vertex right here. My vertex is -1, comma 3. So I'm going to start building f of x is equal to, I have some a. I have x minus, use my colors this time, -1 plus my 3. So you can see where the vertex goes. Just going to clean this up just a little bit. F of x is equal to a x plus 1 plus 3. I'm going to replace f of x with y, and now I'm going to find an ordered pair that's going to work. I would love to have started this entire process with the x-intercepts, but at this moment it looks like my x-intercepts are not crossing perfect grid marks, so I'm not going to use the x-intercepts. I'm going to use this point. I could use this point. So this point hits grid marks. This is 0, comma 2. Or this one, I'm going to choose -4, comma 2. In this case, what I'm going to do, since there are times in which it's not going to cross the y-axis nicely, but it will cross grid marks, I'm going to use the grid. So I'm going to have 2 is equal to, and again, I need to have my squared here and my squared here. I don't know why I keep forgetting that today. Maybe I just don't like it today. So I have a, my replacement for x is -4 plus 1, the quantity squared, plus 3. So I'm going to get 2 is equal to, I have -4 plus 1, which is -3. Squared is 9, so I have 9a plus 3. Subtract 3 from both sides, so I get -1 is equal to 9a. So -1/9 is equal to a. So my function f of x is equal to -1/9 x plus 1, the quantity squared, plus 3. And then if I were to expand this out, I have -1/9. I have x squared plus 2x plus 1 plus 3. So I end up with negative 1/9 x squared minus 2/9 x minus 1/9 plus 3. Continuing to add the negative 1/9 and 3, so I have negative 1/9 x squared minus 2/9 x. Fraction magic over here. I have negative 1/9 plus 3 over 1. I need to multiply this by 9 over 9 to have a common denominator. So I have negative 1/9 plus 27 over 9. So we know this is going to be plus 26 over 9. All right, so pause the video right now, and I want you all to work out what you're going to do for the next one. And I will start you out. Your vertex is 3, negative 1. And I'm looking for a nice grid mark, and here is a grid mark, or here is a nice grid mark. Notice on this one, it does not cross the y-axis nicely. So I could use 6, 7, or I could use negative 1, 7. Again, I will start you out here. Here is your vertex. Your vertex is negative 1, 2. And nice grid marks. Let me see. Oh, here's a nice grid mark. It does actually cross the y-axis nicely. So I'd probably use this one, 0, negative 1, or I could use this other one, which is negative 2, negative 1. So go ahead and pause this and see if you end up with the correct answer. Okay, welcome back. What I have for part B here is I ended up with f of x is equal to 1/2 x squared minus 3x plus 7 over 2. And for this second part, or part D, I've got f of x is equal to negative 3x squared minus 6x minus 1. Now let's talk about the coefficients on all of these, the A part, and see if we could have just reasoned with some of the answers. So this one is the parent function that has been moved. The vertex has been moved from 0, 0 to a negative 1 up 2. And then we notice that the other thing that happens is that it goes through the points that we would expect with a quadratic without the parent function, or the toolkit of functions without a vertical stretch. So I would have gone up 1 and over 1, got that point, and from there I would have gone from the vertex, I would have gone up 4 and right or left 2. So this we knew is correct because the leading coefficient should be a positive 1. It is open and up. We have no vertical shrink or stretch. For this graph, what we see is we ended up with that negative 1/9 as a leading coefficient. Negative says, yeah, we're opening downward. It's the U kind of shape is opening downward. And the 1/9 is a compression. So we have taken this and we have compressed it vertically. That vertical compression, as we can see, is that we've squished it in the vertical direction, results in a horizontal stretch for quadratics. Same thing happened here. I have a vertical stretch of 3. Negative says I am opening downward. And what that does is for a quadratic, that vertical stretch of 3 does a horizontal compression. So kind of cool, right? You're like, no, it is kind of cool. To find the x and y intercepts, what we're going to do is do what we always do. To find the y-intercept, you let x equal 0. To find the x-intercept, you let y equal 0 and solve. Finding the vertex, you can complete the square and put it in this form, or you can use this where h is equal to negative b over 2a. Again, we will cover this in calculus, why it is this way, why we can quickly go there. So on this example, they're asking us to find the vertex, the axis of symmetry, any maximums or minimum values. I'll actually give you where it happens too. The intervals of increasing and decreasing, the x and y intercepts, and the domain and range. And you're thinking, okay, can I just put this in Desmos? Sure, you can put it in Desmos. You don't get that on the test though, so no, you probably don't want to do that. So I'm going to start with the vertex. So first thing I'm going to do is find the vertex. What I'm going to do is I'm actually going to zoom in so that I can have lots of space, because I like to write big and there's a lot I have to do. So the first thing I'm going to do is find the vertex. And B is equal, or excuse me, H. I'm so excited to find the vertex. I started out with B. H is equal to negative B over 2A. A is -1, B is 10, and C is 23. So this is going to be -10 over 2 multiplied by -1, and so I end up with 5. To find the K part, this is f of 5, or f of h if you like. So I'm going to write this as -5, the quantity squared, plus 10 multiplied by 5 plus 23. So this is -25 plus 50 plus 23. So this is 25 plus 23. So I end up with 48. So my vertex, my answer for this part is going to be 5, 48. Now the second part, what is the second part asking us to do? The second part is asking us for the axis of symmetry. This is lovely. This is just a line y or x is equal to the h part, which is 5. The third part, what is the third part asking me to do? What is it? The maximum value? Okay. So because my leading coefficient is negative, the maximum value is the k part at x equals the h part. So we have a max of 48 at x is equal to 5. Intervals of increasing and decreasing. So that's the number 4. So since we know the leading coefficient is negative, that means we're going to have some graph. Actually, I'm not even put the x and y axis because I'm not sure where it's going to cross. And so I just know the shape's going to look like this. Here's the max. So that tells me that everything on the right side of x is equal to 5 is going downhill or decreasing. Everything on the left side of 5 is increasing. So increasing intervals, increasing is going to be from -infinity to 5, and decreasing is going to be from 5 to infinity. The x and y intercepts is next, but I'm going to do the domain and range, so I'm going to jump to 6. So I'm going to do 6. We like the domain. It is everything. We have no restrictions on the domain. The range, we can see from the graph, is going to start at -infinity to my k part, which is 48. And you're like, hey, wait a minute, what? What if I don't have a graph? Well, because we know the leading coefficient is negative, the vertex, the k part of the vertex will be the maximum. So we know without the graph that since that k part is the maximum, it's going to go from -infinity to that maximum. Now let's actually find the x and y intercept. So let's do 5 now. The y-intercept is easy. We let x equal to 0 and solve, and so we have y is equal to, I'm going to come over here, and the only thing that doesn't have an x attached to it is the 23. So if I put in 0 here and here, I'm just going to get 23. So -0 squared plus 10 multiplied by 0 is 23. So my y-intercept is an ordered pair. It is 0, 23. My x-intercept, I let y equal 0 and solve, and I have 0 is equal to -x squared plus 10x plus 23. We know that this thing does not factor, and you're like, how do I know that so quickly? Because this is a prime number. Prime numbers aren't going to factor into 10. This is not going to happen. So I have to use a quadratic. A is equal to -1, B is equal to 10, and C is equal to 23. So x is going to be equal to plus and minus, so sorry, back up the quadratic formula. -10 plus or minus the square root of b squared, which is 10 squared, minus 4. A is -1, C is 23. All over 2 times -a, or a. The quadratic formula is x is equal to b plus or minus the square root of b squared minus 4ac all over 2a. All right, so x is equal to negative 10 plus or minus, and I plugged in this square root of 10 squared minus 4 multiplied by negative 1 square root of 23, and I ended up with 192, which is the square root of 64. Let me write that. The square root of 64 multiplied by 3 all over negative 2, which is negative 10 plus or minus 8, the square root of 3 all over negative 2, which becomes, with simplification, and I'm going to break it apart now, the negative 2, I can rewrite this as negative 10 divided by negative 2 minus 8 divided by negative 2, the square root of 3, which gives me 5 plus 4, the square root of 3. And x is equal to negative 10 divided by negative 2 plus 8 divided by negative 2, the square root of 3, which gives me 5 minus 4, the square root of 3. Now, as ordered pairs, I would write this as 5 plus 4, the square root of 3, comma 0, and 5 minus 4, the square root of 3, comma 0. If you want to use decimal equivalents, that's okay too. Unless it says you have to do exact, you can use the decimal equivalent. Okay, so that's the first one. And we have, I'm going to do it one more time, and then I'm going to give you the answers for the next two, and then we're going to do an application, and then that should be it for this video. Yeah, we got a couple of applications, and then that should be it for this video. Okay, so once again, I'm going to start with the easy part, which is the x, or the vertex. So h is equal to negative b over 2a. A is 1/2, b is negative 4, c is 8. So I have negative 4 over 2, negative 4 over 2 multiplied by 1/2. So I get just 4. And the 2 and the 1/2 will cancel, making 1. Double negatives make it positive. The k part is f of my h part. So f of 4. So I have 4 squared over 2 minus 4 multiplied by 4 plus 8. This ends up giving me 16 divided by 2, which is 8, minus 16 plus 8, and so we end up with 0. Oh, that's lovely. That's so lovely. So our vertex is 4, 0. And I'll tell you why it's lovely in a moment. Right now we're just so excited because it's lovely. The second part is they're asking me for the axis of symmetry. X is equal to 4. The third part is asking whether or not it's a max or a min. Because a is greater than 0, we know we're going to have a min of 0, the k part, at x is equal to the h part, which is 4. Now I believe they want intervals of increasing, decreasing. Just we know that this graph is going to look like this. So at this vertex is the location it's going to go from increasing to decreasing or decreasing to increasing. So my intervals of increasing, remember this is x is equal to 4. My intervals of increasing are going to be from the value of 4, these are the x values, the value of 4 to infinity. And decreasing is going to be the values of negative, it should be a parenthesis, negative infinity. So negative infinity to 4. Let me see. The next part, I believe, is asking for the intercepts, which we'll do in a minute. I'm going to do my domain and range next, then I'll do my intercepts. So I'm going to skip to 6. My domain is everything. And my range, because it's U-shaped going upwards, is going to start at the y part of the vertex, or the k part, which is 0 to infinity. And now I'm going to go back and do my x and y intercepts. So we'll start with the y-intercept first. So when y equals, so the y-intercept, that means x is equal to 0. So I have y is equal to 0 squared divided by 2 minus 4 multiplied by 0 plus 8. But I knew that the only thing that doesn't have the variable attached to it is that term that is 8. So I have y is equal to 8. So as an intercept, these are ordered pairs, it'll be 0, 8. God, that was a terrible 8. Almost looked like an infinity kind of trying to be an 8. Okay, and then my x-intercept. So the reason I loved the fact that I have the vertex at 4, 0, that means it tells me my x-intercept. Like it tells me when y is 0, x is 4, and I only have one x-intercept. But I'm also going to show it to you this way. So 0 is equal to 1/2 x squared minus 4x plus 8. Now I'm going to multiply everything by 2 to get rid of the fraction. So that means the left and right side, 0 times 2 is 0. X squared minus 8x plus 16. And so this does factor. It's a perfect square trinomial. It is x minus 4, the quantity squared, so it tells me that x is equal to 0. And so my x-intercept, or x is equal to 4, excuse me, not 0. X is equal to 4. So I have the x-intercept and one and only one at x is equal to 4. And so if I were to graph this, by the way, my intercept up here for my y-intercept is 0, 8. I have the vertex, which is 4, 0. My axis of symmetry is here, and it's going to look something like this. Now, I know that if this distance horizontally is 4, and then this distance horizontally to this other point has to also be 4 because of the axis of symmetry. All right, so I'm going to have you do these next two, and then I will give you the answers. All right, so for the next one, which is C, these are the answers that I got. For the first part, where they're asking me for the vertex, we ended up with fractions. 5/2, and when I got done, I got 11/4. Question number 2, where they're asking me, what is the question number 2? The axis of symmetry. X is equal to 5/2. The third part, where they're asking me the max or min, the leading coefficient is positive, so you're going to have a min of the k part, which is 11/4, at the h part, which is 5/2. The next part, since we know this is opening up like this, we're going to have intervals of increasing. So here's number 4. The increasing intervals are the k part, which is, or the x part that produces the uphill, which is 5/2, infinity. Decreasing is going to be negative infinity to 5/2. Those are my intervals of increasing, decreasing. My domain on range. So my domain and range, so I'm going to jump up to 6 actually, so this is 6. My domain, of course, is everything. And my range, because it is a U-shaped parabola opening up, it's going to start at the k part, which is 11/4, and end at infinity. Now, I'm going to go back to this. My y-intercept, I got it to be 0, 9. And then the x-intercept, I have none. And the reason I have none is because when I went to throw this into a quadratic, I got a complex number. So x-intercept, none. And that's because when I went to do the quadratic formula, I had x is equal to -5, so 5, plus or minus the square root of -5 squared, or just 5 squared, because the negative will cancel, minus 4 multiplied by 9 all over 2. This produces a negative. So I can stop right there and I say I have no x-intercepts. If it asked me for the solutions, I would continue, but it's not, so I have no x-intercepts. So we take a look at D here, my vertex. So the first part, my vertex is the ordered pair 3/2, 17/2. My axis of symmetry is x is equal to the h part, which is 3/2. My max or min, since I know my leading coefficient's positive, it is also going to be opening up. So I'm going to have a min of my k part, which is 17 over 2, at the h part, x is equal to 3 over 2. The next part is intervals of increasing, decreasing. So increasing happens at the h part to infinity. So this is 3 over 2 to infinity. The decreasing is going to go from negative infinity to the h part, which is 3 over 2. I'm going to skip to the domain and range because that's easier. So my domain, again, is everything from negative infinity to infinity. My range, because it's opening up, it starts at the k part, which is 17 over 2, and goes to infinity. Now I'm going to go back to the x-intercept. So I'm going to start with a y-intercept again because it's the easier one. My y-intercept is 0, 13. My x-intercept is once again none. Why? Because when I throw this in the quadratic formula, I'm going to have x is equal to 6 plus or minus, because it's negative b, so negative 6, the square root of negative 6 squared, or in other words, I could have just wrote positive 6 squared, minus 4 multiplied by 2 multiplied by 13, all over 2 multiplied by 2. This is negative, so I can get a solution. The solution will be complex. That means I have no x-intercepts. Okay, so now we are going to look at these two application problems, and then that will be it for this video. A stonemason has enough stones to enclose a rectangular patio with 60 feet of stone wall. If the house forms one side of the rectangle, what is the maximum area the mason can enclose? So we actually seen some of this in chapter 1. We were talking about intuitively about domains and ranges, and I gave you the graph. And I said we're going to go in this later. So here it is. We're going to go into it. So let's draw a picture because I like to draw pictures. Here's my house. And here's where I'm going to fence. I'm going to make this x, this y for no reason. Now, that tells me that the perimeter is going to be this x plus this y plus this x. So I have x plus y plus x has to equal 60. So I have y plus 2x has to equal 60. We also know that the area is going to be an x multiplied by y because it's a rectangle. The area of a rectangle is one side multiplied by the other side. Two equations, two unknowns. Let's take this y is equal to and solve for the first equation. Y is equal to 60 minus 2x, and let's put it in right here. So I have the area is equal to x, 60 minus 2x. Let's multiply this through, and I get the area is equal to 60x minus 2x squared. Now, I know if I rewrite this in the appropriate form, which is negative 2x squared plus 60x, this is a quadratic shaped like that. And we know when it's shaped like that, the max is going to happen at the vertex. So all I have to do is find the vertex. So h is equal to negative b, which is negative 60, over 2 multiplied by a, which is negative 2. So I have 60 divided by 4, and that is 15. So when x is equal to 15, I know what the max area is. So a of 15, because this really is a function of x only here, is going to give it to me. However, I can go back to here and just put it in right there, right? So to find the y part, but I'm going to do a of 15 is equal to negative 2, 15 squared plus 60 times 15. I'm going to get my calculator out because I can't do that in my head. I wish I could. Actually, I don't wish I could. I just can't. So negative 2 multiplied by 15 squared plus 60 multiplied by 15. So my max area is 450. Now I need to pay attention to the units. So the max area is 450 feet squared. I have one of the dimensions, so I have one of the dimensions, which is 15 feet. I need to put that 15 back into that y. So y was equal to 60 minus 2 multiplied by x, which is 15. So y is equal to 60 minus 30, so y is equal to 30. So my dimensions are 15 feet by 30 feet. And I said earlier, hey, I can just plug that in. If I multiplied these two, I'm going to get this answer. So I can find the max area by putting the h part back into the original function. Or in this particular case, I could have found the y, multiplied it by x, and I'll still get the same thing. Oh, these tick marks mean feet. So these tick marks mean feet. I'll do one more application, and then that's going to be it for this video. And you're like, thank God, because this thing's long. I know it's long. Could be longer. Could make it longer. You don't want me to. I don't want to. So here we go. The path of the object projected. Oh, actually, you know what? I'm going to make it longer. Let's talk about the domain and range of this. So if I were to graph this here, this equation, that if I set each one of these factors equal to 0, I'm going to get x is equal to 0. So if I were to graph this, I'm going to have x is equal to 0. So this is where it's crossing the x-axis at x is equal to 0. That comes from this one. And if I set this equal to 0, I'm going to get x is equal to 30. So 30. So this is an application. The domain for this does not make any sense to include 0. And it doesn't make any sense to include 30. So non-inclusive. And it doesn't make any sense to go to the left side of 0 or the right side of 30. The range on this one is I'm going to start, and it's non-inclusive. So let me erase that and put non-inclusive because obviously I can't get 0. All the way up to my y part, which was 30. And it does include that 30. So that's your domain and range for that application. So I made it longer, sorry. The path of an object projected at a 45-degree angle with an initial velocity of 80 feet per second is given by this function where x is a horizontal distance traveled and h is the height in feet. At what time did it reach its maximum height? And what is the maximum height? Okay, so we have to pay attention to the fact that x is a horizontal distance. It is not the time. So the first thing we're going to have to do is figure out what the maximum height is, and then figure out how long it's going to take us to get there. So at what time, we'll answer that, but it's not going to give it to us right out of the gate. And what is the maximum height? So first of all, we have to figure out what the x that produced the maximum height, and then we can figure out the time based on that. So at what time? So the h part is going to be negative b, so negative 1 over 2 multiplied by the k, or the a part, which is 32 over 80 squared. And I'm going to rewrite this as, and this is a negative here, I'm going to rewrite this as the double negatives will cancel itself out. And since this is a fraction, I'm going to rewrite this as a positive 1 because this negative here cancels with this negative. And it is the numerator fraction, which is now a positive 1, multiplied by the reciprocal of the denominator fraction. So the reciprocal of this is going to be 80 squared over 2 times 32. All right, so I'm going to do this in my calculator, 80 squared. And it's going to be divided by 2 times 32. And I get h is 100. So when you shoot this rocket off, right? And I know it's going to start here at 0, 0. And you're like, how do I know that? If you set this thing equal to 0 and solve, you're going to have x, factoring out an x. And then you're going to have negative 32 over 80 squared x plus 1. So this gives me x is equal to 0. Now, if I go 100 feet, right? If I go 100 feet, I'm going to hit my max height, whatever that is. Okay? That's what this is telling me at 100 feet. Now, because of symmetry, we know the axis of symmetry is x is equal to 100 because that is the h part. all I have to do is go another 100 feet in this direction, and I'm going to get that symmetry, so I know it's going to look exactly like this. Of course, drawn better than that. I am not here to draw great pictures. So I know that if I set this thing equal to 0, I'm going to get x is equal to 100. Excuse me, 200 feet. Okay, so I found my x and y intercepts, but that's not necessarily what it's asking me for. It's asking me for the time it takes, and it also is asking me for my max height. So my max height, x is equal to 100. My max height is, I'm going to go back to my function, and I'm going to put in the 100. So I have negative 30 equals negative 32 over 80 squared multiplied by 100 squared plus 100. So again, I'm going to get my calculator out, and I have negative 32 multiplied by 100 squared divided by 80 squared, and then I'm going to add 100 to it. And so my maximum height is only 50. Okay, so now we have the maximum height. Here's the maximum height. It is 50 feet at x is equal to 100 feet horizontally. But that still doesn't answer what time. How long did it take us? So what we're going to do is we're going to cheese it. Like, we need calculus to actually figure out the distance traveled, this arc length here. We're not going to do that for this class. We're just going to say, we're going to cheese it and say, let's figure out how long it took to travel 100 feet horizontally to make our lives easier. So we know we went 100 feet. Its rate was 80 feet. So I end up with 10 over 8. So we have, we ended up with 1.25, because it makes sense to write this as 1.25. My units are feet per second, so it took 1.25 seconds. That's how long it took. Again, we are cheesing it. We're just going to go the horizontally. How long did it take to go horizontally 100 feet? And it took about 1.25. To find the actual answer, we need calculus. So we're going to leave it at that. And then how long was the object in the air? Well, so if it took 1.25 seconds to get to the halfway mark, it must be 2 times 1.25 seconds to get to the ground. And so it's just multiplied by 2, and I end up with 2.5 seconds. And that's it for this video. It's kind of a long one. Have a great day.